Hello, hello, hello. Hi, everybody. Good evening, good morning. I'm audible to all.
Yeah, good morning.
Yeah. So I need someone to volunteer with the system who has not installed any of the tools. Anyone can volunteer the system because everything is done in my system. Again, if I have to show, I have to reinstall everything. Anyone would volunteer?
Sure,
Anyone? Like
sure,
Vaishnavi,
I
can you?
can. Yeah, sure, I can.
Okay, I'll give you, you can start sharing your screen.
Okay.
So today's agenda is all about installing the tools. First half is all about installing the required tools. Vaishnavi, if possible, can you connect your laptop charger?
Sure, yeah. Mm, Yes, done.
Thank you. So let me open the notepad file. So what are the tools that needs to be installed? One is JDK 25. So other question that we always ask is like, Rahul, if I have already JDK 17, is it okay? Or JDK 811, is it okay? No. The minimum JDK version that we all recommend is JDK 21, guys. Okay. If you are using JDK 8 or JDK 11 or 17, I will recommend all of you to migrate to 21 or 25. Okay. The editor that I'll be using in the class is IntelliJ IDEA. Then I'll say git bash. So these are the three primary tools that we need to install for now. Any other tools that requires to be installed, we'll be discussing in the further classes. I hope I'm clear at this point.
Yeah.
Hmm? So if you want to download JDK 25, search for JDK 25 download. Go to the official, go to the official site of this thing. Go to Java downloads, official site of Oracle. So JDK 26 has been released. Well, I'll check this and keep you posted. Okay. Go to JDK 25. Go to Windows. If you are a Mac user, go to the Mac user. In the Mac user, ARM64 means it's an Apple chip. N264 means like the Intel chip. So just check your, based on your chip, you need to select the DMG installer. If you are a Windows user, Manju, if you have 21, that's fine. Okay. So I need to click on Windows. So I click on 64-bit installer. Always go for 64-bit installer. So I click on this link. It'll take some 3, 4 couple of minutes to download the file. Okay. Once you once the software is downloaded and you click on install, there'll be a pop-up coming up. So Vaishnavi, did a pop-up come like, do you want to make changes to this device system?
Yes, yes, yes.
Yeah. When you get this pop-up will not be visible in the Zoom meeting. But when you get that pop-up, click on yes. So what we need to
Yeah.
do here, click on next, next. It'll take hardly 1 or 2 minutes for JDK to be installed. Okay. So I click on close. Once this is done, then we need to set the environment path. What do you mean by this environment path, Rahul? We see in a lot of videos. What is the purpose of it? The purpose of using environment path is to let the command, like when you're executing any Java programs via command prompt or via some external source, we want the we want the command prompt or any terminal to know that this is where my Java libraries are present. How do we get your bin path of Java? Go to C, program files. So JDK 25. So let me copy this and I search for environment variables, edit the system environment variables. So go to the path. The path which is present. No, 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 not here, Vaishnavi.
Sorry. Oh, sorry.
So,
Is it the Java?
yeah, okay. You need to replace Java home with 25, JDK 25. Can you
Okay.
double click it? Yeah. Replace 21 with 25. That's it. Yeah, remove the slash bin. Okay. Can you go to your path?
Um,
Path. There's a
this
path,
this one?
right? Yeah. No, no, no. Not under the user variables, the
Ah,
system variables. Yeah.
okay. Okay.
Okay. So can you remove this thing? Can you remove?
21 version, right?
Yeah, yeah, yeah. Could you remove 21
Okay.
and uh click on new? Yeah, paste it. Yeah. So what we will do here is, so before bin try to don't close it. Before bin try to remove everything. Before bin try to remove before slash bin try to remove everything.
Okay.
Yeah, use slash bin slash
Yeah, just a minute. I'm searching for the backslash.
backslash is present near
Yeah.
this. Yeah.
Yeah. Yeah.
So before that type, before the backslash type,
Okay.
percentage
Okay.
Java underscore home, the capital letters, what the variable you have declared there.
Okay.
Percentage, that's it. So what we are doing here already, Vaishnavi has configured the Java home variable. Instead of duplicating every time, whatever variable I stored in Java home, I'm calling that variable here. Okay. So click on OK button. You click on OK.
Okay.
Cool. Once I click on OK, what next? Let's install git bash download. Again, this git bash download is only for Windows. For Mac, for Linux, git is installed by default. Okay. So download git for Windows 64-bit. So once it is downloaded, double click on it. So there will be a pop-up coming. You need to click on yes. So I click on next, 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 next. So here you are using Vim as the Git default editor. That means what? Whenever you any merge conflict occurs, whenever any uh, reverts you are trying to do, what is the default editor? The Git shall use. So if you are not comfortable with using this tool, what I recommend, can you click on the drop down, Vaishnavi?
Okay.
So here you have options. You can use Notepad++, you can use VS Code as your editor for all these things. So you can choose either of the option. If you're comfortable with the default one, you can go with the default editor. If you want to change, you can select Notepad++ or Notepad as per your requirement. So Vaishnavi, it's your call. Like you want to use Notepad or you want to use the default option, that's your call.
Like in future, I can still change it to
Again, you
Notepad or
have to type
something.
one. Yeah, you can change, but you have to type the command, like git command again.
So which one will be comfortable, Rakesh? Uh,
Okay, okay, I'm Rahul.
Sorry, Rahul. Yeah.
So I use VS Code personally,
Okay.
but it's not necessary that every system shall have VS Code, right? So you can go for Notepad better.
Okay. Okay.
Okay, click on next. So yeah, click on next. Yeah, yeah. Just click on next, next, next till the end.
Okay.
Install. Can Eclipse be made as a default editor? Manju, I didn't get your question. Manju, could you repeat your question? I mean, which editor you're talking about? Default editor for Git or for the course?
Yeah, for the Git, instead of this notepad, can we make the Eclipse as a default
Uh,
editor to
mm,
change?
I mean, go for Notepad. Every system has a Notepad, right? For that reason, I'm saying.
Okay.
Click
So
on
do I need to
finish.
launch? Not required.
Not required. Just click on finish. Yeah, just once. There'll be some release notes showing up. Okay. So,
Sorry.
yeah, no worries. So for this course, we are going with IntelliJ IDEA. You can also use Eclipse, that is not a problem, but the latest features of Java, what we are using, will be highly flexible in IntelliJ because they are one of the prime sponsors to Java Oracle. So let me click on download. So now IntelliJ is a single unified product. So what will happen here? The moment you install IntelliJ, for the first 30 days, you will be getting the full premium version of IntelliJ. After 30 days, if you want to continue with the subscription, you can pay the amount. Else, there will be something called as community version. After 30 days, it will roll back to a community version of IntelliJ. Got it? When you're installing IntelliJ for the first time in your system, for the first 30 days, you'll be getting a trial period of the premium version. After 30 days, it will roll back to community version. You need not pay even a single rupee for that. Okay?
Is that automatic or
It's automatic.
okay?
So this is slightly heavier tool to install as there are a lot of plugins present as part of the IntelliJ. Nowadays, IntelliJ is becoming the go-to editor for the past 3-4 years over Eclipse. So can you double click on this, Vaishnavi?
Okay. Will it take time? I did actually.
Yeah, that pop-up came. Do you want to allow?
No, it didn't come.
Wait. Hold on then. It
Okay.
should come ideally. Or else do one more time, double click. There shall be a pop-up coming up ideally. Wait for some time. Any message you're getting unpacking something like that pop-up?
No.
Okay, go to your downloads folder and let's try. From here, it's not working once. Double click. Now it is opening. Many pop-ups coming up.
I'm not seeing any pop-up.
But it started. It'll take some time, I guess. Okay.
Yeah,
Yeah,
it's
it came.
coming now.
It came. Okay.
Yeah.
Click on next. Next. Create desktop shortcut. Vaishnavi.
Okay.
Yeah. Create associations dot Java. In create association, select dot
Okay.
Java. Yeah. Click on next.
Okay.
Install.
Yeah.
And the remaining, these two buttons are flickering here, right, Vaishnavi? The
Uh,
two
yeah.
setups. Yeah, close. Click on cancel and close them.
Okay. We clicked so many times.
Mm, mm.
Yeah.
Anyways, IntelliJ will take some time to install. Okay, click on finish. Now all the three softwares are installed. So if you're Linux user, like can you go to the browser once?
Yeah.
There's the tools here. So if you're a Linux user, you need to change your wait. If you're a Mac user or Linux user, you can change here automatically. Okay. So with this, everybody is clear, right? What are the tools that needs to be installed? Everybody in the room. Aisha, Manju, Rakesh, Suraj. Great. So thanks, Vaishnavi, for volunteering.
Can I stop sharing?
I have stopped it.
Thank you.
So before we step into Java programming language, all this stuff, so there's a very, very, very fundamental question that I want to ask from everybody. Not related to programming, not related to anything. That's a simple question. Now, the question here is, what are the different components of a computer? Let's go from real scratch, guys. We are not starting with Java, absolute Java. Let's understand what is a programming language. Let's keep it from real scratch. So before going to programming language, what are the different components of a computer? Anyone? What are the different components of a computer, guys? Guri, Manju, Malinath,
The
anybody?
disk, CPU,
Mm-hmm.
memory,
Yeah, RAM,
Motherboard.
ROM, RAM, hardware, CPU. Major components of any computer. It can be a laptop, it can be a desktop, mobile, anything. Even mobile also we say as a small size, small kind of a computer, right? It's a mini computer we say, right? Right. So, what is the most important component in devices like desktop, mobile, or laptop? It is known as processor, which is also which is the processor. Processor is the main component, which is the brain of your computer. Like in desktop, we say it as CPU. In laptops and mobile, we say it as processor. We say high-end processor we require, high-end graphic cards we require for while purchasing the laptop. I want 2.7 Intel gigahertz processor or 3 gigahertz processor. So processor is the main component, which is the brain of your computer. So what is this processor? What is it responsible for? Suppose if you want to play a music, or if you want to play any games, if you want to code something, then processor is responsible for each and everything. It is the brain of the computer. Without processor, we cannot do anything. How many of you is clear? It's clear, right?
Yes.
yeah.
So this might look slightly silly, but bear with me for 1 or 2 days just to help you understand what is the programming language, how the science has started. Then you'll understand the whole architecture of why Java, what is Java, and all those things. Now, how these processors or CPUs are manufactured? With the help of semiconductors. With the help of semiconductors, because it is lightning fast in terms of execution speed, and they use the concept of transistors. Clear? Now, if you see, if anyone follows news or something like that, in India, this year budget, they are planning to have more semiconductor factories, more made in India semiconductor factories, because we are living in a semiconductors era. Now, in the AI world, behind the AI world, behind the scenes of so much happening in the AI, there is a dark market, black market for semiconductors. Without semiconductors, none of your AI LLM models will not work. None of your programming language work. None of your systems will work. That's how the powerful is a semiconductor. How many of you know this, guys? Without semiconductor, there's nothing. Hmm? How many of you know behind the scenes without semiconductor, there is nothing, right? Yes or no? Silence doesn't work, guys. In my class, yes or no? Yeah. Now, the biggest AI word that you see in the news or market is not because of the LLM models. It's because of the computing power, processing speed. We are in a race of acquiring more and more semiconductors. More and more RAM war is happening because we are shortage of semiconductors. The semiconductors which is manufactured is not meeting the required demand. So, if you learned in your college days, engineering days, transistors are of two types. PNP and NPN. Transistors don't understand English language, don't understand anything. Transistors understand only two things: low voltage and high voltage. So, how it understands which is low and which is high voltage? Low voltage means it is 0. High voltage means it is 1. You might ask me, Rahul, do they really focus on this in the time of interviews? It is not for interviews. We are here to understand the concept of a programming language right from a scratch. So that when someone asks you, what is Java, why it is platform independent, what is the story behind it, you will understand the whole story right now. Is processor intelligent enough to perform operations by itself? Absolutely not. Absolutely not. Because it is a dumb device where we need to provide instructions, provide the required instructions from time to time to perform the required operations or get something out of it. Clear? Now, as I have told you, the processors can understand. So behind the scene of processor, we are using a transistor. Now the question is, you told me it's a dumb device. We have to give the instructions from time to time. So if we instruct the processors in English language, will it understand? No, absolutely no. We shall instruct the processor in such a way that it can understand. What it can understand? It can understand the binary number system. It can understand the binary number system. What is binary number system? Zeros and ones. As I've discussed prior, low voltage and high voltage. That means it understands the instructions written in zeros and ones. Clear? So the instructions we write in such a way that machine understands is called as a machine level language. Got it? Now we are passing the instructions in the form of zeros and ones. That is known as a machine language, popularly known as MLL. Clear, everybody? Any doubts? What is a machine level language? What is a processor? How it is understanding the science behind it? Cool. Now, if I say I want to convert the number, like I want to send the word, suppose automation to the processor, it does not understand the word processor. Again, you have to, which cannot understand. Again, now we have to convert each and every alphabet to a binary number. Got the point? You have to convert each and every alphabet to a binary number. Clear? Which is a difficult one because we don't know how A will be processed as a binary number. We know how U will be processed as a binary number. We don't know any of such sort. Okay. Then came the concept of, okay. Now this is the major problem. What is the major problem? Now, what is the major problem that we are encountering here? Major problem is that humans cannot write instructions in binary format. Okay. And processors cannot understand the way we pass the instruction. So what is the thing? After years of research, we have coined the word mnemonics in the year 1960. Clear?
Okay.
To make the human life easy. This is your first ever programming language. If you want to speak in the history of programming language, mnemonics is your first ever programming language. Forget JavaScript, forget Python, forget everything. Okay. So here we come up with the concept of ALL, that is assembly level language, where we write the instructions in the form of mnemonics. We write the instructions in the form of mnemonics to make the life easy, to make human life easy back in 1960s. Not now, back in 1960s. Okay. So how do we write mnemonics? Like suppose I'll say add 5 plus 8. So what we'll write in programming language, any programming language, how we'll write, we'll say print 5 plus 8. Okay. But in ALL, what we will say? We will say add 5 space 8. So in your college days, in your engineering days, you must have seen the writing the code in assembly language and all these things. When I say add 5, 8, what does it do? Internally, the code will be converted to machine level language. Internally, the code will be converted to machine level language and interact with the processor. This is the first ever programming language that has been invented, guys. That is ALL, assembly level language. Clear? So imagine that this is a CPU where you have a couple of transistors, P and P transistors. CPU, processor, anything means the same. Okay. Now, whatever machine level language that we have written, that is, what is the machine level language? Some instructions 0 1 0 1 0 or 1 0 1 0 1, something like this. So what I will do, I'll be passing to the CPU, and CPU will process it and returns the output. Clear?
Just one question, maybe it is amateur.
No
So
worries, no.
when we say like it's a heavy processor, so which of these components like will be more in the CPU? Is it like it will have more of this PNP, NPN or something?
I mean, it's a mix of PNP and NPN transistors. So NPN is used for fetching the data, PNP used for sending the output.
Okay, so when we say like a processor is heavy, like um, what makes it heavy?
The number of tasks that you're trying to perform on it at the same time.
No, no. I mean, how it is able to process like
So
uh,
everything is converted into machine level language, na? So when I say everything is
uh,
converted to,
no,
yeah,
no, no, that was not my question. Like you say this processor is heavy and this processor is like not that heavy. Like what makes it heavy and light?
heavy and light based on the task that you're performing, based on the operations that you're performing in that particular CPU, based on the how we are using the cores of the CPU, how we are using the CPU resources. That
Uh,
defines it.
Maybe she's expecting the capacity to process the data.
Ah,
That's
okay,
where
yeah,
okay.
yeah, yeah.
In those terms, like, see, why we always say like you have to buy a 2.7 gigahertz processor, 3 gigahertz processor. So, in order to perform heavy computation operations, in that case, I'm saying.
Okay, okay. Yeah, thank you.
So, back in the olden days, when you talk about 1990s, 1 gigahertz processor was like a nightmare manufacturing those kind of chips. Okay. Now, as I've told you, we are in the era of ALL, that is assembly level language. If you are from EC background, I'm sure someone of you must have done this mnemonics once in your lifetime, right? Clear? Now, what does it do? Internally, what does assembly language level language does? It compiles the code into the machine language. Got it? Clear? Any doubts so far? All good? Good to go, guys.
Yes, it's
But
clear.
yeah. But what was the challenge now? We have got mnemonic language, but that's fine. The but writing the instructions in mnemonics was a nightmare when we want to design some complex stuff, when we want to design some complex tasks or complex activities. Because you need to remember the keyword, you need to remember those operations and all. And it was not at all, it was not human friendly at all. Clear? Again, after years of research, they had they have decided to use symbols instead of add, subtract, multiplication, division, etc. Clear? an English-like language, which is now known as HLL, that is high level language. Now this is the terminology you might have heard most of the times. In order to avoid the challenges that mnemonics is giving to you, we are going for the HLL called as high level language. HLL can be also be known as high level programming language. Now we understood the journey of what is high level programming language. Everybody is clear what is mnemonics, what is high level programming language, why it has come into picture. Now everybody understood, right? How the journey has started. Vaishnavi, Rakesh, Manju,
Yes.
Yeah.
Yes, Rahul.
right? Guri.
Yep.
Now we are writing something in high level language. Now, who is responsible? Now, who is responsible for converting the code into machine level language? Now we are writing something in English standard. Who is responsible for converting the code into machine language? Here comes the concept of compiler, will help us convert the HLL to MLL. I'm using the short-term terminologies, guys. So, from late 1960s onwards, we use HLL to communicate with the processors. Is this clear, guys? Now we understood the journey of compiler. Now we understood why high-level programming language. Now why we say all this Java and things are high-level programming language. Cool.
Yeah.
Okay. Now you might wonder, Rahul, you told me about semiconductors. You told me about passing the instructions to the programming language in a very neat manner. Now the concept here is, just a moment. Sorry guys, I just got a call. Now, how many of you have this question in the mind that Rahul, a lot of things are happening with the semiconductors. Now, how are we storing the files? How are we storing the information? How this communication is happening? Has anyone had this doubt? Suraj, Rakesh, Malinath, Guri, Lata. Has anyone had this doubt, right? Yes or no?
Yep.
Now, this is a CPU. What we have here is a CPU, and which is purely semiconductor tech. So this is the backend science behind any LLM model or behind, LLM model, the transformers, the embedding vectors, those are all things are there. But behind the scenes, if you go more deeper about LLM models or any machine or something like that, this is the core component. This is the core crux of it to understand things. So we have a hard disk drive. Back in the olden days, hard disk was the only storage. Now we'll have cloud drives and all. Hard disk drive, which was first invented by IBM in the 1950s. Invented in the year 1950 by IBM. The first hard disk in the world has been manufactured by IBM. Okay. It was built using electromagnetic technologies. Back in those days, it was built using electromagnetic technology. Okay. Which is super slow in nature. Okay. So what is happening? What is happening now? If you see here, in order to communicate the hard drive with the CPU, what is happening here? We need to have a bus to have a continuous back and forth communication. Okay. This is called as a CPU. This is called as a bus. Bus is nothing but a ways of communication between the bus concept. It is a set of wires that carries info from one unit to another unit. So you go to any data center, you say that AWS cloud is there, everything works on cloud, nothing, no local setup is required. No? You go to any AWS data center, or you go to any Google data center. What they have is the whole physical infra setup for you. The whole physical infra setup on the cloud. That means the physical infra is accessible over the internet. That is why we call them as cloud. Okay. You will see all these wires loaded between the machines, between the CPUs, processors. You will see all these things loaded, guys. Okay. Now, what is happening here? As I've told you, it is super slow in nature. Now, if I'm sending a set of if I have a set of instructions and I want to pass it to CPU, it is very slow in nature. It might take 10 minutes or 15 minutes to reach to the CPU. That means data in the bus will not be transferred that easily from hard disk to CPU directly. The data will be processed in the form of small chunks. That is the reason it was very slow. Back in those 1950s and 60s, we had computers which was very slow, very big in nature, because directly the hard disk was interacting with the CPU, and fetching the data from the hard disk was like a nightmare because it was very slow in nature. It will take a lot of time to do it. Now, if you see as per this architecture, within the same system, we have a mismatch. We have a speed mismatch. What is a speed mismatch? Semiconductor is fast in nature. This hard disk is very slow in nature, which reduces the efficiency of the system. Is this clear, everybody? What was the major challenge back in those days when they were manufacturing the computers? Directly, the hard disk was interacting with the semiconductors. So hard disk is very slow in nature, CPUs are very fast in nature, and there is a complete speed mismatch. Clear? Now, after couple of years of research, they have invented a device called as RAM. RAM stands for Random Access Memory. Now you understood the reason why we say more RAM capacity, more faster the system. We will understand why we say that. Where more RAM, more faster the system. So it is built using semiconductor technology. It is used to improve the efficiency of the system. It is fast, compact, and less noisy. Why we say less noisy? If you see back in those olden days of IBM computers where there was no RAM in the early 1950s or 1960s, whenever we start a machine, it used to make a sound like a factory machine. It used to make a sound like a factory machine, like literally we are working inside a factory. That noisy it was when we are operating on the computers in the 1950s or 1960s. Now what is happening here? Now, instead of maintaining the data in the hard disk, what the team has decided now, I have a CPU. Now, I have a RAM. Now I have a bus technology. Both are built using semiconductors. That means both will be fast. Bus technology. Now what is happening here? Faster communication. Why it's faster communication between this system? Faster communication. Faster communication because both of them are built on semiconductor technology. That is why both are faster in nature. Now the data processing was quick. The data processing was fast. But what is the problem? What is the problem with semiconductor? Semiconductor always require continuous power supply. Always remember, semiconductors always require continuous power supply. Once the power supply is gone, the data is lost. Once the supply to the power is gone, supply of the power is gone, the data will be vanished. Got it? Second thing, semiconductors are expensive to purchase. Now, you see the advantages, I'll have a faster communication. But the main disadvantage of this architecture is, as a semiconductor, I always need to have power supply. Once the power supply is gone, I cannot capture any data or something like that. So what happened in the early 70s? They have realized that RAM is the game changer and they have decided like I will build a system based on RAM and CPU integrations. Now, what happened again? Then they realized that RAMs can't be maintained as it is very huge in nature. So what did they do? They brought the concept of hard disk again. The hard disk which was built using electromagnetic technology. Got it? Again, I have a one more bus, a set of wires that establish communication between the two systems. Got it? Now, what is happening here? Now, HDD, that is hard disk doesn't require demand for continuous supply of power. It is non-volatile in nature. Okay. Is the architecture clear for everybody?
Yep.
Yes. This is the real architecture behind your laptops, behind your computers. I mean, this is the overall architecture, high level design architecture. I'm not giving you very proper OS components like kernel and all those things. Okay. Even inside any LLM model where it is like GPT LLM model or anywhere also, this is the fundamental layer. Based on this layer only, you will see all this prompt engineering concept, interaction with the LLM models and all these things. Okay. Without this knowledge, it will be difficult. Now, what is the behavior here? So if I want to save the changes, I'll be writing it to the HDD, that is hard disk, saving changes. Now, if I want to load something, I will have to bring the file to the RAM. Now, the question here is a very, very simple question. Now, I ask you to type a document inside a Word. You will interact with RAM or you'll interact with the hard disk. Can anyone tell me?
RAM.
RAM. So,
Unless we save it.
sorry?
Unless we save it, then it goes to the hard
Yeah.
disk, right?
Yes. When we write any document or any code, we write it inside a RAM so as to have faster communication with the CPU. Once we want to save the changes, then only we use the concept of hard disk. Hard disk is used to store the changes, not to load the changes, not to manage any operations. Clear? We always write our code or write our documents or perform any computer activities on your RAM. That is why we say more RAM space, better the execute, better the performance. Higher the RAM space, higher the performance of the system. Now you got it, guys. Whenever we buy a laptop or purchase a laptop, we say, I want higher RAM specs or higher RAM configuration. So that when we perform heavy coding operations or when we perform some complex operations, we'll have a lot of memory. Clear? Is this clear, guys?
Yeah, Rahul.
Yes. So inside a machine, RAM is known as a main memory and HDD is known as secondary memory. Always remember that not only in systems, in any LLM models, anywhere across the globe, this is the thing. That is why whenever we learn about AI, ML or any system-based design, first you need to understand the high-level architecture of the CPU, how it interacts with the semiconductor. Because if you don't understand the concept of semiconductors, there is no point in using any LLM model or any AI tools or any Java, nothing. If you don't understand this architecture as an IT guy, then it's useless. Clear?
Okay.
So, process of getting the data from hard disk to RAM is called as loading. Sometimes you say like loading issues are coming while opening a file because the data from the hard disk is not being loaded to the RAM on time, on queue. That is the reason. Clear? Storing the information permanently to a file, permanently to HDD is called as a file. Clear? Whenever you're storing the information to the hard disk, that is called as a file.
And Rahul, who is responsible for fetching data from hard disk?
There is a bus
Uh,
connection, right?
okay,
Bus
I mean
communication.
but what controls the speed or if it's loading, it could be slow, it could be
So
fast, right?
slow. See, ultimately hardware is designed on different technology. RAM is designed on a semiconductor technology. So that is why there will be a mismatch in terms of speed. Now the hardware technologies are more robust, more crisp. That is why you are seeing loading of data quickly.
So basically, if you use SSD in that case, that's more faster because
Yeah,
the technology
SSD
is
more
better.
faster because it's
Okay.
more faster in terms of communicating with the RAM. SSD is more
Okay.
faster. HDD is not that faster. That is why when we go in the market, like how much you buy an SSD one, man, don't buy an HDD one for faster communication with the RAM and processor.
Okay.
It's because of the semiconductor technology.
Right. Okay.
Okay.
Sounds good.
Okay.
Clear?
Yep.
How many of you felt this concept were interesting? Okay. How many of you felt this was interesting, guys? This is I mean, I never teach all these things, but in the world of AI, in the world of software engineering, I felt like knowing all these things is must and should. Because without knowing all these things, you write some prompt and you say like it is not responding properly. You need to understand behind the scenes what is happening.
True.
Okay. Storage area in RAM is called as a byte. Like if you want to measure the storage area in RAM, we call it as a byte. Now we understand why we deal always the size of data in the form of bytes, because RAM storage area is dealt in the form of bytes. Now in HDD, we deal the storage area in the form of a files. Clear? Now there is something called as cache memory. That is the last core component of any computer system, which I'll explain it tomorrow. Tomorrow I'll explain the core component, the cache memory. Then we'll start with Java. Got it?
Okay.
I hope you found this topic interesting.
Yep.
Trust me, guys, if you go to any place, even in YouTube also, it will be very layman, very unorganized. I try to keep it very organized for you, very simple and organized. Organized is different thing. Keeping it simple and organized is the key here. Any feedback for this? We are happy to take any feedbacks. Like if you can improvise the content here, we will improvise the content here also. Okay. So clear, everybody. If anyone has any doubts, you can ask right now. Else you can drop.
Mm, No, Rahul, no questions.
Sounds good. And Rahul, what would we start with tomorrow? You said Java, like core Java basics and everything, right?
Basic. What is Java? Why it is platform independent? What is the science behind it?
Okay.
By Friday, we
Rahul,
will start some programming language. Like we'll start the programming part.
do we save these notes somewhere?
I'll try to share with the admin team. They will share you the links.
Okay.
Awesome.
Rahul, for installation at JDK and Get Bash, do you
Mm.
have any document?
I have a document. You can go through that document. Okay. If any changes you want, if you feel like some discrepancy is there, please let me know.
Okay.
And that document would be given to the admin
Yeah,
team, you
I'll
said.
give it everything to the
Okay.
admin team. They'll share it. Else I will post it in the groups.
Okay.
All right.
How do they usually share such stuff? Like on
Actually,
there's
today
a
we are in a demo, so these are all demos, so I am personally sharing it. But once we are all
Mhm.
enrolled, you will be part of the LMS portal that we are onboarding you. Once you are onboarded, you'll be part of the LMS portal. So all the notes, all the class related discussion will be made there only. So you'll be
Okay.
receiving a daily invite of the class. Like whenever we are on leave, you'll be getting the leave notification. You'll be getting all the assignments there. You'll be getting all the live quizzes there. All the materials will be there only. Since we are in the demos, we are doing it all the manual ways.
Okay.
Okay. And all these recordings also for the session would be in that.
Yeah, all these recordings you'll be receiving in a YouTube playlist.
Okay.
Okay. So the notes will
Sounds
be in our LMS portal. The class scheduling, the class agenda, everyday class invites will be done via the LMS portal once you are all onboarded. Like once you guys are onboarded, I'll explain you, I'll give you a quick walkthrough of the LMS portal of what you need to do, what and all is there. Okay. You can, if you are feeling hesitant to raise your doubts in the class, in front of everybody. You can raise your doubts there also. You can raise doubts for anything. You can start your discussion like Guri has a doubt like, hey, I see like these are the questions I asked in the interview. You need not even ask me. Your batchmates can also answer the questions on behalf of me. Got it?
Okay.
So it's like an end-to-end LMS portal, guys. You need not go anywhere. Everything is well configured there.
Sounds good.
Good. So see you all then. Just
Yeah.
keep on practicing it, guys. Thank you, Lata. Thank you,
Thank you.
Manju.
Thank you so much, Rahul.
Thank you.
Thank you.
Thank you,
All right,
Rahul.
bye.
Bye. Bye.
Thanks,
Good day.
Bye.
Rahul.